Good morning, dear students. Welcome back to physics class. In today's class, I would like to discuss on mainly three topics which are A. Hydrostatic paradox, B. Atmospheric pressure, and C. How to measure gauge pressure. From last class, you had studied gauge pressure is the excess of pressure P minus PA at depth h of a fluid. It is the difference in pressure P at depth below the surface of a fluid which is open to atmosphere and atmospheric pressure PA. Then it is mathematically equal to h rho g, that is P minus PA is equal to h rho g. So we can say that gauge pressure is the pressure difference between the system and the atmosphere. From the expression P is equal to PA plus h rho g, where P be the pressure at any point and PA be the atmospheric pressure, we can see that pressure at any point is always greater than the atmospheric pressure by the amount h rho g. Then P minus PA is equal to h rho g, where P be the pressure of the system, PA be the atmospheric pressure, and P minus PA be the pressure difference between the system and the atmosphere. Let us discuss on hydrostatic paradox. What is hydrostatic? You know that hydro stands for water and static stands for at rest. Then hydrostatic means water at rest or water which is stationary. Then what is paradox? Paradox means something taking place surprisingly. Let us see what is hydrostatic paradox. Consider three vessels of very different shapes like thin rectangular shape, triangular shape and some filter shape, or funnel shaped or conical shaped. And we have a source from which water enters into three vessels. Water enters through the horizontal base, which is the base of the three vessels. We observe that the level of water in all three vessels is same irrespective of their different shapes. Here, three vessels are named as A, B and C as shown in given figure, and water is pumped into three vessels. You have seen that water levels in three vessels are the same. You may ask this question yourself: why does the level of water in all three vessels come to same? It is because pressure at some point at the base of these three vessels is same. The water will rise in all three vessels till the pressure at the top should be same as the atmospheric pressure, since all three vessels are open to the atmosphere. As pressure is dependent only on height, therefore in all the three vessels the height reached by the water is same, which is irrespective of difference in their shapes. This experiment is known as hydrostatic paradox. The three vessels A, B and C contain different amounts of liquid, all up to the same height. Next discussing part is atmospheric pressure. What is atmospheric pressure? You know, atmosphere is a mixture of different gases. It is like a blanket consisted of different gases covered with the Earth's surface. All these gas molecules together constitute some weight. By virtue of this weight, there is some pressure exerted by the atmosphere on all the objects. It means that atmospheric pressure is the pressure exerted by the weight of the atmosphere. Then, what should be the pressure of the atmosphere at any point? The pressure of the atmosphere at any point is equal to the weight of a air column of unit area of cross section, which is extending from that point to the top of the atmosphere. Value of atmospheric pressure at sea level is equal to 1.01 into 10 to the power of 5 pascals, which is equivalent to 1 atmospheric pressure, represented by 1 atm. It was Italian scientist Evangelista Torricelli who devised for the first time a method for measuring the atmospheric pressure. This device is called barometer. As mercury is used in this device, it is called mercury barometer. How does the mercury barometer work? It consists of a trough filled with mercury. There is a tube which also contains mercury and it is inverted inside the trough. The one end of the tube is closed and other end of the tube is placed inverted inside the trough, as shown in given figure. The inverted tube, which also contains mercury up to a certain level, and the space above mercury in this tube is occupied by its vapor. The pressure can be considered as 0 at this place. The atmosphere will exert some pressure on the mercury level in the trough. As a result of this pressure, the level of mercury decreases in the trough and it goes to increase the level of mercury in the tube. This increase in level of the mercury will determine how much pressure was exerted by the atmosphere. Let us see how can possible this measurement. The pressure exerted by the atmosphere is directly proportional to the increase in the level of the mercury column of the tube. So, we can say that pressure at the point A is same as the pressure at the point B. It is atmospheric pressure which is equal to H rho g. It is measured in terms of how many millimeters of mercury or Hg rose in the column. Greater the height, greater is the atmospheric pressure. When the height in this column becomes 76 centimeters, it is read as atmospheric pressure is equal to 76 centimeters of Hg. We can say that pressure applied is equal to 1 atmosphere. Then it can be concluded that the mercury barometer works under the principle of gauge pressure, which is P minus PA is equal to H rho g. Here P as PA or P atmosphere and PA as 0. Then P is equal to P atmosphere is equal to H rho g. Let us see what are the units of atmospheric pressure. SI unit is Pascal. Since pressure is always measured by taking sea level as the reference level, atmospheric pressure at sea level will be equal to 1.01 into 10 to the power of 5 Pascal. Next unit of atmospheric pressure is atmosphere. 1 atmosphere is equal to 76 centimeter of Hg at sea level. Here also we have used the reference level is sea level. 1 atmosphere is the pressure which is equivalent of 76 centimeter of the mercury column. Next one is torr. It is the pressure equivalent of 1 millimeter of mercury column. 1 torr is equal to 133 pascals. And another unit is bar. 1 bar is equal to 10 the power of 5 pascals. How can we measure gauge pressure? It is measured by open-tube manometer. It is a modified form of barometer. Mercury is used usually in this manometer. The height to which the mercury column will rise depend on the atmospheric pressure. Similarly, depending on the pressure of the system, the height of the mercury in another tube rises. The pressure difference between these two heights is the difference between the atmospheric pressure and the system pressure. This difference in pressure is the gauge pressure. It consists of a U-tube which is partially filled with a suitable liquid which may mercury. Mercury is used for measuring large pressure differences, but low density liquid such as oil is used for measuring small pressure differences. One end of the tube is open to the atmosphere and other end is connected to the system whose pressure we want to measure. The pressure P at a point A is equal to pressure at the point B. Actually, the measured one is the gauge pressure which is P minus PA, which is equal to rho g H, where H be the difference in heights of the liquid columns in both tubes, which can be readable from a calibrated scale in unit of millimeter or centimeter, which is made on the manometer. Or P minus PA is proportional to manometer height H, since the density rho and acceleration due to gravity g are the constants. Consider if the level of mercury column is same in both the U-tubes, then P atmosphere is equal to P, since P minus PA is equal to 0 as H is equal to 0. Therefore, the difference between the atmospheric pressure and the pressure of the system is equal to 0, so gauge pressure is equal to 0. How can convert the atmospheric pressure in unit of atmosphere into torr? It is P atmosphere is equal to 760 torr. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.